Hello and welcome to Algebra 2 tutorial. In this video we're going to take a look at quadratic applications. Now we've done this once already and we looked at projectile motion mostly. If you throw something into the air, it makes a parabola. But we can also use it for profit curves and modeling how much money you would make when you're selling something or doing some sort of event. So let's take a look at this scenario and how we can use quadratics to model profit curves. So a company is modeling what their profits might be for a concert they are holding. Obviously, your profit depends on the price of your tickets. And so there we have quite a bit of information. I'm hoping that sentence makes some sense, but your profit is the dependent variable and the price that you're selling the tickets for is your independent variable. So the function p of t equals this models our profits. So first let's see how that can make some sense and why that is the case. So this is a parabola and the negative 40 in front means it is upside down. Now yes, the numbers are big, but don't let that throw you off. We have an upside down parabola. Now I'm hoping if you see here, if we have on the bottom our ticket price, and over here we have our profit on the y-axis. There is some ticket price that's too low where our profits are 0. And if we raise the ticket price, we make more money. But then if our ticket price gets too high, fewer people will start coming because it's too expensive, and your profits will actually start to go down. And there is a point where you're charging too much money where your profits will get back down to 0. And which is why we get this parabolic shape for profit. So hopefully in general it makes sense why we can use a quadratic to model a profit curve. So let's get into some of the specifics. Our x-intercepts are the first characteristic we're going to look at in the context of this problem. So we have this profit curve. We're going to find the x-intercepts and then explain what they mean. So this is a really big equation. I think the best way to do this is just try out the quadratic formula. So negative 2,000 plus or minus the square root of b squared negative 40 squared minus 4 times a, oops, I did that wrong, didn't I? My bad. B squared, I said it, but I didn't write it correctly. B squared minus 4 times A times C divided by 2A. So I would recommend definitely doing this on a calculator. There's a lot of pieces there where you could make a mistake if you try to do it by hand. So let's do the inside of the square root first. So 2,000 squared minus 4 times a, which is negative 40, times negative 16,000. So there we get a really big number, 1,440,000. But then we need to take the square root of that number. So since I've got it in the calculator already, I'm going to do the square root of that number, 1,440,000. And we get 1,200. So now I'm going to start writing some of this down. So we have negative 2,000 plus or minus 1,200 divided by, and 2 times negative 40 is negative 80. And so I'd say let's take that and turn that into two answers. So we get negative 2,000. I'll do plus 12. Oops, I had a little mistake there. 1,200, isn't it? And divide that by negative 80 So our first answer is 10. Let me fix my mistake here. 1,200, not 12,000. All right, now let's do the other one. Negative 2,000 minus 1,200. I did it again. Divided by negative 80. So that is 40. Two nice answers. All right. So those are our x-intercepts. So let me bring up the quick little sketch we had last time of our parabola, and we now know some numbers. The first x-intercept is at 10, and the second intercept is at 40. So remember, those are points. Our first one is 10, 0, and the second one is 40, 0. Those are our x-intercepts. So the x value, which in our function we have as the letter t, is the ticket price, and the second one is the profit. So if we charge $10, our profit will be 0. If we charge $40, our profit will also be 0. So those are the two extremes where we will make no money. We won't lose any money, but we won't actually make any money. And so if we charge $10 or $40, our profit will be 0. And so one way this question could be asked is, what ticket prices will cause the company to break even? That would mean that the profit is equal to 0, and you need to find your x-intercepts. So again, we're not losing money, but we are breaking even if we charge $10 or $40. All right, so those are our x-intercepts and what they mean in the context of this problem. Let's go on to the next one. So we found our x-intercepts. What about our vertex? Our parabola definitely has a vertex. What does that point mean? So our vertex, remember, x is equal to negative b over 2a. And so first we'll find that. So negative 2,000 divided by 2 times negative 40. So that is negative 2,000 divided by negative 80. The zeros cross out there, so 200, they become positive. 200 divided by 8. Let's do that real quick. 200 divided by 8 is 25. So that's the x value. Now what about the y value? What is the profit if we charge $25? So we just plug it in, negative 40 times 25 squared plus 2,000 times 25 minus 16,000. So let's do this. We'll do 25 squared times negative 40 gives me negative 25,000 plus 2,000 times 25 brings me to 25,000 minus 16,000 brings us to a total of 9,000, it looks like. So P at 25 is equal to 9,000. So if we charge $25 for a ticket, we're going to make $9,000. But if we go back to what our parabola looked like, here was, what was it, 10, I believe. It goes up, and comes down, and over here was 40. 25 is in the middle. If I go all the way up to the top where the vertex is, 25, 9,000. That is not only our profit, that is the maximum profit. It's never going to go higher than that. So our maximum profit is $9,000. And so if you got a question, what is the maximum profit a company can make? That is telling you you need to find the vertex. All right, so that's our vertex. What else do we have here? Increasing or decreasing. So find the intervals when this function is increasing and decreasing, and what do those intervals mean? We've done most of the hard part already, and so I'm just going to redraw this. We've got our parabola. So it goes up. So at first we are increasing, and then the parabola goes down, so then it is decreasing. And we already know where it stops doing one and starts doing the other, right at the vertex at $25. So if we're less than 25 over here, the parabola is increasing. And if we're bigger than 25, the parabola is decreasing. So if, I'm not going to use x, I'm going to use t. If t is less than 25, then p at t, our profit curve, is increasing. And when t is greater than 25, on the other side, p at t is decreasing. Now, what does that actually mean in the context of our profit curve and the ticket prices? Well, when we are increasing, if we increase the price of the ticket, our profits go up. So that's what it means when the profit is increasing. If we increase the ticket price, our profit goes up. But once we pass the $25 mark, now if I increase the ticket cost, our profit goes down. And so if we increase ticket price, our profit goes down. So it's always talking about this x change first. If we increase the price, our profit is going up, 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 until you get to here. Now if I increase the price, my profit is starting to go down, starting to decrease. All right. So that gives us a good example of how to apply our quadratic profit curves to, our quadratic equations, our parabolas to a profit curve, something other than projectile motion. Hopefully that makes some sense. Good luck.